So you're a homeschool parent guiding your student into the middle school years. And let's be honest, that shift into sixth grade math, it can feel, well, absolutely monumental. If just glancing at a set of sixth grade math problems is totally stressing you out or maybe making you worry about learning gaps, I want to validate that right now. It is completely normal. The math is getting way more abstract, the stakes feel higher, and suddenly we're asking students to think in entirely new ways. But here's the really fantastic news. You absolutely don't need to be a math genius to help them succeed. You just need the right map. So in today's explainer, we're equipping you with an energetic, actionable toolkit to help your student confidently cross this monumental bridge.
To cut through the overwhelm, we've got a clear, structured roadmap for exactly how we're going to tackle these core concepts. We'll start with crossing the math bridge, then we'll jump into visualizing ratios and proportions, building number line fluency, variables and fraction division, virtual tools for real data, and finally untangling math word spaghetti.
Section 1. Crossing the Math Bridge.
Okay, so first things first, we really need to reframe how we view this whole academic year. Sixth grade isn't some terrifying new world you have to conquer blindly. Think about it. On one side, you have the basic elementary arithmetic your student already knows, right? Adding, subtracting, multi-digit numbers, basic fractions. But then on the far side is high-level algebra, expressions, variables, equations, which, let's be real, can seem pretty daunting. Sixth grade is literally just the space that securely connects the two. It introduces foundational algebra while still relying heavily on that basic arithmetic they've already mastered. We're just building a secure bridge over to the abstract.
So what exactly is this bridge built out of? Well, it essentially boils down to 5 core pillars. First up, ratios and rates, which is really just all about describing relationships. Second, the number system, meaning things like dividing fractions and navigating those tricky positive and negative numbers. Third, expressions and equations, which is where that foundational algebra truly kicks in. Fourth is geometry and measurement for calculating area and volume. And finally, statistics and probability for summarizing data. Honestly, once you see it broken down into these 5 specific categories, the whole year looks a whole lot less intimidating, right?
Section 2. Visualizing ratios and proportions.
You know, when students first hear terms like ratio or unit rate, it can honestly sound like total gibberish to them. But visual models absolutely change the game here. Using things like proportional bars makes those abstract relationships instantly concrete. A student can literally see that for every 3 parts of one thing, there is exactly 1 part of another. It's like having 3 blue circles for every 1 red circle. These visuals perfectly bridge that annoying gap between word problems and mathematical logic. Seriously, make this your absolute go-to strategy. Before you ever have your student write out an equation, have them draw it out. It lowers the stakes completely and turns an abstract idea into something they can literally hold in their mind's eye.
Section 3. Building number line fluency.
Now let's shift gears to the brand new challenge of crossing 0 and heading into the negative zone. We'll start with a rock-solid definition so you're perfectly equipped to guide your student. Rational numbers are simply any number that can be written as a fraction. And crucially, this includes both positive and negative numbers on the number line. Before this year, your student mostly just dealt with positive numbers, but now they've got to figure out what exactly happens on the other side of 0.
To teach this, we want to get physical. I highly suggest creating a giant, colorful number line stretching all the way across your living room floor. Maybe push the coffee table out of the way first. Have your student physically jump along it. They step forward into the positive numbers, and then they physically step backward into the negative space. Tying that physical action of jumping to an expanding number line helps students intuitively internalize exactly where numbers live, rather than just blindly memorizing what a minus sign means. When they instinctively know exactly where negative 2.5 lives compared to positive 3, moving on to graphing on a full coordinate plane later in the year is going to be an absolute breeze.
Section 4. Variables and fraction division.
Okay, now we have to tackle what are arguably the trickiest concepts of the entire year. Let's just acknowledge reality for a second. When an abstract variable like x or y suddenly pops up in a math problem, students tend to just freeze. The math panic sets in. So how do we introduce these letters without causing a total meltdown?
The trick is to connect that variable to a tangible real-world object first. So instead of just saying x plus 5 equals 10, frame it for them like this. Okay, we have a mystery box of apples plus 5 loose apples on the table, and that equals 10 apples total. How many apples must be inside the mystery box?
Making variables completely concrete like this is a proven, highly effective strategy. It playfully tells the student that x isn't some scary, incomprehensible letter, it's literally just a box we haven't opened yet. Then we have to tackle the beast that is dividing fractions by fractions. We really don't want students just robotically memorizing a dry formula, like keep, change, flip, without having a clue as to why it actually works. You've got to help them logically reason through it. The thought process is simple. First, visualize the problem. Second, reason through the division. And third, develop mental math strategies to check the work. To put this into practice, ask highly relatable questions. For example, if the problem is 3 divided by 1/2, ask them, hey, how many halves fit into 3 whole pizzas? Instantly, they can picture 3 pizzas, cut them down the middle in their mind's eye, and count 6 halves. Breaking the logic down with concrete, delicious pizza builds genuine mathematical reasoning.
Section 5. Virtual tools for real data.
When we look at statistics and probability, as a homeschool parent, you actually have a secret arsenal of free, high-energy, interactive resources right at your fingertips. There's a complete treasure trove of digital tools out there that let students literally play with math on their screen. We're talking about virtual manipulatives, where they can construct and dissect geometry, digital chance experiments, virtual dice, and digital coin flips. And look, these aren't just silly games. They are highly effective, super engaging ways to reinforce the curriculum while completely avoiding those boring, dry worksheets.
If you want to truly cement those statistical concepts like mean, median, mode, and range, follow this core piece of advice. Collect and analyze real data with your student. It's so easy. Just pull up a virtual die on your screen, roll it 50 times together, track the results on a piece of paper, and then use that exact, personalized data to calculate your statistics. It instantly transforms a standard run-of-the-mill math lesson into a dynamic, real-world experiment that they actually have a stake in.
Section 6. Untangling math word spaghetti.
This brings us to the ultimate overarching strategy for those massive, intimidating word problems. I absolutely love this phrase from our sources. Visualize the problem before you try to solve it. Don't feel like all you have is word spaghetti. Think about it. When a 6th grader looks at a paragraph-long word problem, it honestly just looks like a jumbled mess of text. Total word spaghetti. But you can empower them to stop, take a breath, and draw it out. Whether they're drawing proportional bars, circles, or a mystery box of apples, visualizing the problem first untangles all that spaghetti into clear, actionable math.
At the end of the day, math isn't just word spaghetti, it's a fascinating puzzle. Yes, the transition to high-level algebra is a major milestone, but look at this toolkit you have now. You've got visual models, physical logic, and digital data right at your fingertips. So the real question isn't whether they'll cross the bridge, it's what kind of unstoppable problem solvers they're going to become once they reach the other side.